Welcome to section 7.3, which is working with integrals that involve sine and cosine, and then secant and tangent. To do these types of problems, we're going to be using a lot of Pythagorean trig identities. Now, it's very important for you to read your notes. Okay, so this next slide has part of your notes, has number 1, what are you going to do if the power of sine is odd but positive? What are you going to do number 2 if the powers of cosine is odd and positive? What are you going to do 3 if the powers of both sine and cosine are even and non-negative? Okay, so please read through your notes because we're going to get started on our first example. So when I look at example 1, sine's power is odd, cosine's power is even. This is a perfect example of number 1. So what we're going to do is we're going to pull one of those signs off and save it. So we're going to save that sine of x dx. Okay, so we're going to save that. That's going to become our du. So that means sine squared, we're going to have to change that into cosines. Okay, so when we do that, that's going to be, I'm going to start it over here because I'm going to need lots of room. So sine squared is 1 minus cosine squared times cosine to the 4th. And then that's saved up over there. So all I've done is peel that sine cubed apart, saving 1 for the du. Okay, we are going to multiply that out. So 1 times cosine to the 4th, and then cosine squared times cosine to the 4th. We still have that sine of x dx. Now we've got the perfect u substitution. So I'm going to let u equal our cosine of x, and that means du is going to equal negative sine of x dx. So we have almost everything we need. I'm just going to put in my little -1 and counteract that with a -1 as well. And then we're ready to go. -1 times our integral u to the 4th minus u to the 6th du. So when I integrate that, I'm going to have negative u to the 5th over 5 minus u to the 7th over 7 plus my c. And then, of course, I'm going to go ahead and take that negative through and change back from u. Okay. So if you have sines and cosines together, if the sine is odd, then you're going to peel one off, change the other into your cosine. Now, that works when the cosine is well. So step 1 and step 2 are very similar to each other. All right, now number 2, that is our number 2. So basically, anybody that is odd, you're going to peel it off. One of them is going to be involved in the du. The other one is going to have an even power, which you're going to use your Pythagorean identity to help you out. So this guy, we're going to rewrite. This is going to be cosine squared of x times cosine of x over sine to the 1/2. Oops, no. And don't forget your little dx there. So I'm going to change that cosine squared into 1 minus sine squared. Okay, that's all going to be our du. And I am going to go ahead and divide that up. So 1 divided by sine to the 1/2 power is going to be sine to the -1/2 power. And then this is going to be sine to the 3/2 power. and I've got that times my cosine of x dx. So I'm going to do a u substitution. My u is going to be my sine. My du is going to be cosine. Okay, so when I rewrite, this becomes much nicer. No little negatives here. I've got u to the negative 1/2 minus u to the 3/2 du, which is going to give me 2u to the 1/2 minus 2/5 u to the 5/2 plus c, and then don't forget to substitute out. If you want to put it back as a radical, that's perfectly fine. Yay! So that'd be our final answer. Okay, well, example 1 was type 1. Example 2 was type 2, so I've kind of not made it very exciting for you, sorry. This, of course, is going to be type number 3. I don't have a sine and a cosine. I don't have any negative or any odd powers to pull one off of and use as a u substitution. So I'm going right into it. Cosine to the 4th power, well, that's the same thing as cosine squared. I know it looks a bit goofy. Oh, nice dx there. But cosine squared is 1 plus cosine of 2x divided by 2 squared. Okay. So all I've done is a little bit of multiplication. That guy right there is everybody in here. Okay, so I'm going to FOIL that out. That 1/2, I'm squaring it, so I'm going to pull that out as a 1/4. So now I just have my 1 plus 2 cosine of 2x plus cosine squared 2x. And then everything here looks pretty good. I've got my 1 plus 2 cosine of 2x. I'm going to split this integral up into 2 separate integrals. Because I need to do that little trick again. Okay, so when I do that little trick again, this little guy is going to stay just like it is. This little guy I'm going to have 1/4 times my 1 plus cosine of 4x all over 2 dx. Okay, so this integral right here, the second one, I'm going to go ahead and separate it. So I have my 1 1/2 here, sorry, kind of dozed off there for you, dx. It's 1/2 cosine of 4x dx. And then I have all of this stuff right here. Now, when I look at this little guy, everywhere I see an angle that's not a 1x, I would do a baby u substitution, but we know that when I take that integral, I just have that 1/2 sine, my 1/4 sine. So when I integrate all of this nice information here, okay, I'm going to integrate, so I'm going to have 1/4. And notice I have 1/4 in front of everybody here. Here's my 1/4, 1/4, 1/4. So I'm just going to pull that 1/4 out in front. Okay, and then I have x plus sine of 2x plus 1/2 x plus 1/8 sine of 4x. plus c. So I pulled that 1/4 out that was in front of all of the integrals. I can leave it like that. I can get them all together, whatever I need to be doing there. I do have an x and a 1/2 x here, so that's 3/2 x times 1/4, which is going to be 3/8 x. And then that looks like that's about the only thing I'll be able to add together. So it's a little bit I could add together. Okay, so here's my final answer. So whenever you don't have a sine or a cosine, there to help us out with the du, the process gets very fun algebraically. Okay, now the process for doing secant and tangent together is very similar. Okay, I'll let you read through those notes so you know what to do if the power on secant is even and positive, if the power on tangent is odd and positive, etc., etc. Okay, note there are 2 additional factors. If there are no tangent factors and the power on secant is odd, you're going to have to use integration by parts. If none of the first 4 guidelines applies, try converting into sines and cosines. So secant and tangent might be just a little bit trickier. So looking at number 1 here, I got a little more creative, so you couldn't just do number 1 was case number 1. So looking at number 1 here, try to figure out which of the following cases do we have. Okay, this turns out to be number 2. I have a lot of tangents, so I'm going to pull one off. Now you'll notice in step 2 there it says I need a secant as well. Oopsie, secant to the 1/2 x. Well, we're just going to have to wait on that for a minute. Well, tangent squared is secant squared minus 1 okay, so I still need more for my du to make it happen, but we're going to get there. Okay, then I'm just going to simplify. That's going to give me a secant to the 3/2 power minus secant to the negative 1/2 power. All of that is times tangent. Now that number 2 there, it says I need a secant, so look at what you got here. Both of these terms have a secant involved, so I'm going to factor a secant out. Now it's a little weird because this guy is now a secant to the 1/2 power, and this guy is a secant to the negative 3/2 power. I can't help that the powers got gross because I need that secant tangent to join together to become my du. So this guy along with this guy is going to be my du. So u, of course, is going to be secant. Du, the derivative of secant, is secant tangent. So now I get to rewrite this mess again as u to the 1/2, whoopsie, minus u to the negative 3/2 du. So when I integrate, I get 2/3 u to the 3/2 minus 2u to the negative 1/2 plus c, and then rewrite 2/3 secant 3/2 x minus 2 secant to the negative 1/2 x plus c. Now this negative 1/2, you can put it in the denominator. You can change it to the cosine to the positive 1/2. It's all in what you might want to do. Okay, so let's look at number 2. This is actually an example of our first type. So that secant, I'm going to split that apart. My secant squared, times tangent cubed. Okay, so this time I needed a secant squared because that's going to become my du in the future. So the other guy, we're going to have to change him into tangents. So I'm going to rewrite that guy. And then that's going to be 1 plus tangent. Oh, goodness gracious, it's just all running together. 3x tangent cubed of 3x dx. Simplify, and then do your u substitution. So that'll be tangent to the third, tangent to the fifth. Okay, so now when I do my u, that's tangent of 3x, which means du is going to have to be secant squared, got it, times 3. Ooh, don't got it. So I have to put that 3 in, counteract that with a 1/3. Not a problem. You just have to pay attention to your u substitution. So we now have 1/3 u to the third plus u to the fifth, all du. So that's going to be 1/3 u to the fourth over 4, u to the sixth over 6, let's see, and then substitute that back out. So I have tangent to the fourth over 12 plus tangent to the sixth over 18. Let's see. So you can kind of get the idea that secant and tangent, they form each other's derivative. So you just kind of got to look at who's the odd man, who's the even man, see if you're going to do a u substitution with tangent, then you better have secant squared as its derivative. If you're going to let u be secant, then you're going to need a secant and a tangent. Okay? All right, so number 3 is type 3. I've got tangent to the fourth, so I'm going to split it apart. Okay, so I'm going to do tangent squared and tangent squared. I'm going to change one of those tangent squareds into secant squared, because right now I don't have my u sub. I don't have anything. Okay. So I'm going to multiply that together. So I end up with tangent squared secant squared minus tangent squared. Okay. Now this one is, believe it or not, ready to go. I'm going to use a u substitution. I'm going to use the u as tangent. Because I have his derivative, which is secant squared. And this little guy becomes u to the second du. Okay. Now over here, I'm going to take this back to secant squared minus 1. And I will, of course, be able to integrate that because I can integrate secant squared and I can integrate 1. So when I integrate that first part, u to the second, that's going to be u to the third over 3, and then minus tangent of x plus c. Took that negative through, and then of course I can't leave an answer with u in there. That'd be craziness. So remember what your u was? It was tangent. So tangent cubed of x divided by 3 minus tangent of x plus c. So knowing those trig identities and knowing what you can integrate and what you can't integrate is going to be super, super important. So look back over those two